Welcome to the deep dive. We're here to cut through the noise, get straight to the insights you need, really just to be well informed. Today, we are peeling back the layers on something that's, well, it's rapidly reshaping our world. Large language models, LLMs. Imagine like a digital entity that can write poetry, debug code, even get into complex philosophical debates. How did we even get here? What's the secret sauce behind this seemingly magical intelligence? So we've taken a stack of your sources, articles, research papers, our own notes, all focused on LLMs. Our mission here is to pull out the most important nuggets, give you a shortcut to being genuinely fluent in how these fascinating systems work, what they can do, and crucially, what their limits are right now.
And that last part is absolutely vital.
Mhm.
Understanding these systems isn't just for developers or tech enthusiasts anymore. It's fast becoming a fundamental literacy, really, for everyone. It empowers you to engage with AI as an informed participant, not just a passive consumer.
That's a really key distinction. Yeah. So get ready. We've got some surprising facts, relatable insights, maybe just enough humor to keep you hooked as we unpack this uh, digital brain. Okay, let's start with the big question. How do LLMs even begin to get so smart? Because it's not magic, right? It's this sophisticated, data-driven learning process.
You're right. It's definitely not magic. It's all about scale and statistical learning. LLMs learn from just an unparalleled amount of information. Think of it like consuming a colossal digital library of human knowledge. We're talking billions of books, articles, online chats, entire websites, even student essays, emails, pretty much anything you can imagine that uses human language. This huge exposure is what lets them grasp the intricate patterns and relationships within language.
Okay, and this is where it gets really interesting, I think. The core learning mechanism.
Hmm.
It's basically incredibly sophisticated pattern recognition. They're just constantly searching for statistical patterns.
Exactly. Think of it like a system learning that the phrase once upon a time almost always signals, a fairy tale. Their main goal during training is just to predict the most probable next word in any given sequence. So if you feed, I want to build a sandcastle at the boo, the LLM will probably predict beach. Why? Because its training data has overwhelmingly linked sandcastles with beaches. But here's the really crucial insight. This is purely statistical probability of word sequences. They don't have human-like reasoning or consciousness or real-world understanding. And this fundamental design, that's exactly why they can sometimes hallucinate, confidently make up plausible but totally wrong information or echo biases found in the data they learn from.
Right, so it's a super sophisticated prediction machine, not something with actual comprehension. That difference feels critical. And underneath all this prediction and pattern matching, there's this fascinating architecture. What does that digital brain actually look like?
Well, it's called a neural network, and it is loosely inspired by the structure of the human brain. You can sort of picture it as an intricate web, maybe, a web of interconnected processing units. Information flows through it, transforms across multiple layers, and each layer kind of builds on the complexity of the one before
An intricate web. I like that analogy.
it.
Can you break down what those processing units, those layers, actually represent in this digital brain?
Sure. So each individual processing unit is called a neuron or a node. Think of it like a single junction point in a huge network, or maybe like an individual student in a large classroom working together. These neurons are organized into distinct layers. Data gets processed step by step through these layers, sort of refining the information as it goes deeper. And the connections between these neurons, they have weights. These are just numerical values that represent the importance or the strength of that connection. And these weights, they're constantly being adjusted during training. There's a process called backpropagation. Basically, if the LLM makes a prediction that's wrong, the error gets calculated and sent backward through the network. This prompts adjustments to the weights. It's like a continuous feedback loop, almost like a teacher correcting mistakes, refining the model's guesses with every single try.
Wow, okay. That continuous self-correction is, well, it's pretty amazing. So we've got how they learn, what their structure looks like.
Mm.
Now, how do LLMs technically process language and then generate text? It starts by breaking down our language into something they can compute, right?
Precisely. They have to break text down into smaller, more manageable units. These are called tokens. Think of it like slicing a sentence into puzzle pieces, or maybe like Lego bricks for language. These tokens can be whole words, sometimes parts of words, or even just punctuation. Each unique token gets a numerical ID, a number that the model can actually work with mathematically. For instance, the phrase, I love playing video games, might get tokenized into something like, I love playing video games. Each gets its own number.
Okay, so just numbers at that point. How do these numbers get meaning? How does the LLM start to understand the context or the relationships between them?
Right, that's the next crucial step. Embeddings. These token IDs, these numbers, are converted into what we call continuous valued vectors. It's a bit technical, but imagine mapping words into a high-dimensional space, like a complex coordinate system. In this space, words with similar meanings get mapped to points that are close together numerically. So the vector for king would be mathematically close to the vector for queen, reflecting their semantic relationship. This numerical representation is essentially how the LLM understands word meaning and relationships. And critically, it's also how patterns, including any biases present in the human training data, get encoded into these mathematical relationships.
Got it. And then there's the real magic, or maybe the real cleverness behind modern LLMs,
Yeah.
the attention mechanism. It's part of their transformer architecture, right? What's
Yeah.
so special about that?
Oh, the attention mechanism was a total game changer. Unlike older models that processed words sequentially, transformers, using attention, can simultaneously examine the relationship of each word in a sentence with all the other words in that sentence. It's kind of like, imagine skimming a long paragraph, but your brain instantly focuses only on the parts that are truly relevant to the main idea you're looking for. Or maybe like a map navigation system that considers the entire road network and traffic, not just the next turn. This ability lets the LLM grasp the full context, the subtle nuances of language much, much better. It leads to far more specific, coherent, and relevant responses. This wasn't just about making them faster, it fundamentally changed them. They went from just interesting language tools to conversational partners that seemed to get what you're saying on a deeper level. It allowed for a depth of interaction that just wasn't possible before.
Incredible. Okay, so after all that complex processing, tokenizing, embedding, weighting, attending, how do they actually talk back to us?
That final step is natural language generation, or NLG. It's where the LLM converts all its internal numerical processing and predictions back into words that we can understand. It basically reverses the input pipeline, taking the mathematical representation and constructing human-readable sentences, allowing it to communicate its answers or generated text back to you.
Okay, that's a lot to take in, but it makes sense.
Ah.
Fundamentally, these elements, breaking language into digital bits with tokenization, giving them meaning through embeddings, processing them in a neural network that learns to pay attention to context, and then using natural language generation to speak back, that's the core of how they work.
Yeah.
And what they can do with that capability, well, it's becoming truly mind-blowing.
Absolutely. I mean, LLMs are the core tech behind the AI assistants so many people use now, like ChatGPT. They help with a massive range of tasks, answering your questions, digging up information, just having a casual chat, or even practical things like setting reminders or drafting a quick email.
But they're evolving beyond just being digital assistants, aren't they? They're becoming powerful partners in lots of different fields.
Indeed. We're seeing huge value in creative and academic support. For writers, they can be fantastic brainstorming partners. Think story ideas, world-building details, outlining novels. Academically, they're useful for getting feedback on essays, explaining really complex topics in a different way, and even offering coding help, like deciphering those obscure error messages we all hate. Plus, drafting emails, summarizing long documents. It's a huge time saver for many professionals.
Okay, and this next part feels like a really significant shift. Looking beyond just chat to something called AI agents. What's that about?
Yeah, this represents a pretty major evolution. Think of the LLM as the brain. AI agents are systems where that LLM brain acts as the core intelligence enabling more autonomous action. So unlike a standard LLM that mostly just responds to your prompts, AI agents are designed to actually take action autonomously to achieve specific goals. This means they can potentially execute multi-step workflows without needing constant human handholding at every stage.
Okay, can you give us a clear example? Because autonomous action sounds like a big leap. What's the difference in practice?
Right, good question. So think about marketing. A standard generative AI might draft a marketing email for you if you ask it to. An AI agent, though, could potentially draft the email, then analyze data to decide the optimal time to send it, monitor open rates and clicks, and maybe even initiate follow-up actions based on how people respond, all without you needing to step in again after the initial instruction. This opens up some incredible possibilities for efficiency, for innovation, and for creating highly personalized experiences, whether that's in business, education, or somewhere else entirely.
That does sound like a major step up. But while all this is undeniably impressive, it's so important we understand their current boundaries. A balanced view means knowing the limitations. We have to talk about what people often call the hallucination problem first.
Yes, it's definitely one of their most talked about characteristics. The tendency for LLMs to, well, confidently make up something that sounds believable when they don't actually have a solid answer in their training data. And it's important to remember this isn't really a bug like in traditional software, it's more like an inherent outcome of their statistical design. They're built to generate probable sequences, not necessarily factual ones. They're not trying to lie. We've seen plenty of examples. Inventing historical details, fabricating legal precedents, generating code for functions that don't actually exist. There was that real world case with Air Canada's chatbot giving completely wrong information about the airline's bereavement fare policy, which the airline initially refused to honor. It shows the real world consequences.
And what about what they learn from us? Because they're trained on vast amounts of human text that comes with its own set of characteristics we need to be aware of, right? The whole bias issue.
Precisely. LLMs learn from these enormous data sets of human-generated text. And that text inevitably contains, well, patterns, associations, and sometimes biased, harmful, or prejudiced content that exists in the real world and online. As a direct result, the LLM can inadvertently reflect the same biases in their responses, sometimes perpetuating stereotypes without any intent. It's just mirroring the statistical patterns it learned. For example, some AI image generators, when asked to depict people in certain jobs, have historically shown a tendency to produce images reflecting societal biases, say, mostly light-skinned men as CEOs and darker-skinned women in service roles. Again, the AI isn't thinking this, it's reflecting skewed patterns in its input data.
Okay. Are there other gaps in their abilities? Things they just genuinely struggle with despite seeming so capable?
Absolutely. There are significant memory and reasoning gaps. For one, they generally have limited long-term memory across conversations. Often, each new chat session starts with a kind of blank slate unless you specifically feed it context from previous interactions within that same session. They don't typically remember you from yesterday. And despite how intelligent they can seem, they also have limited deep reasoning skills. They often struggle with complex, multi-step math problems or intricate logical puzzles. They make mistakes. Remember, they are primarily designed to generate language based on learned patterns, not to perform complex calculations or logical deductions like a human mathematician or philosopher might. And finally, there's the knowledge cutoff. This is a big one. Many LLMs are trained on data from the past and often lack real-time access to the internet. This means they literally don't know anything that happened after their training data was collected. So they can't give you accurate information on very recent events, discoveries, or developments.
It's so important to get that these limitations aren't just minor bugs to be fixed. They seem deeply embedded, characteristics that come directly from their statistical pattern-matching design, which means human critical thinking, human verification. They remain absolutely essential when we use these tools. And this leads us perfectly into our next point. Understanding how they work really shapes how we should interact with them, ethically and effectively.
That's exactly right. And the most fundamental principle here is critical thinking. Don't just believe everything you read from an LLM. Because of that potential for hallucinations, for reflecting data biases, you should never just accept LLM-generated answers at face value, especially for important stuff. It's really imperative to always verify the information provided by an LLM, especially for facts or crucial decisions. Cross-reference with reliable sources, do your homework. Actually, encouraging the LLM to provide multiple perspectives on a topic can sometimes help too. It can surface different angles and stimulate your own critical evaluation.
Okay, so verification is key. How should we view these tools then? Are they replacements for human effort or something different?
Definitely something different. We should always see AI as a tool, not a crutch. They are incredibly powerful tools, fantastic starting points for research, for brainstorming, for drafting. But they should not be seen as a replacement for your own thinking, your own effort, or certainly not as a ghostwriter doing your work for you. Think of a student using an LLM to get an explanation of a complex scientific concept. That's great. But then the student needs to go on and independently solve related problems, articulate their own understanding, and not just copy-paste the AI's explanation.
That makes sense. Using it to augment, not replace. Which brings up a really important question. With AI getting so sophisticated, why do humans still matter so much in this picture?
That's where the really pivotal concept of human in the loop, or HITL, comes in. It's fundamental. HITL basically means having real people continuously providing feedback to AI systems. This feedback is absolutely crucial for their ongoing learning, refinement, and improvement. It's like having a teacher constantly correcting homework, or a coach giving pointers. Humans guide the AI, correct its errors, clarify ambiguities, maybe provide new examples or flag problematic outputs. This collaborative model is foundational, truly. Human involvement helps ensure that AI systems align better with human values, that they remain accountable, and that they operate safely and ethically. Without that human oversight and guidance, the risks of AI developing in unintended ways, generating biased outputs, or pursuing misaligned goals just increase significantly. It also means that many future jobs won't be about AI replacing humans, but about humans collaborating with AI. That interaction, that loop, is key. So just to quickly recap where we've been, large language models, these LLMs, they're powerful digital tools. They learn from immense amounts of text data to understand and generate language that feels remarkably human. And they do this using technologies like tokens, embeddings, complex neural networks, and that clever attention mechanism.
Right. And their applications are already incredibly diverse. We see them in AI assistants, providing creative and academic support, and even acting as the foundational intelligence for these emerging autonomous AI agents that can take action on their own.
But, and this is the crucial but, truly understanding them means recognizing their inherent limitations. Things like hallucinations, the potential to reflect data biases, their memory gaps, their knowledge cutoffs. These all stem directly from their statistical design, not from genuine comprehension or intent.
So when you boil it all down, what does this mean for you listening right now?
It means your critical thinking, your willingness to verify information, and your engagement in this human-in-the-loop approach, providing feedback, guiding the tools. These things aren't just beneficial, they're absolutely essential for using these powerful technologies responsibly and effectively.
Exactly. This deep dive into how LMs work, what they can do, and yes, their inherent imperfections. Our goal is that this empowers you to navigate this increasingly AI-powered world. Not just as a passive user accepting whatever the AI spits out, but as an active, responsible, and discerning digital citizen, someone who can genuinely harness AI's incredible potential while also understanding and mitigating its risks. You are, in essence, an active participant in shaping the future of